Welcome to a new video. In this video I'll solve yet another question about the normal distribution for the program of AI standard level. If you follow this program, make yourself comfortable and follow along. This will be useful. This question will be slightly more challenging. It will take more effort to get to the final answer, but it's a very good practice. So with that being said, follow me along on my blackboard. So here's the question, yet another normal distribution question with a little more challenge to it. But that's nothing to worry about because we're still gonna keep it light, keep it simple, right? So we have Yejin works in an office with room temperature that is approximated by normally distributed with a mean of 19.5 degrees and a standard deviation of 0.75 degrees Celsius. Okay, so we have the temperature which is normally distributed. Perfect. I'm gonna write it right here. Temperature is normally distributed and we have the mean of 19.5 and then the variance of 0.75 squared. So remember, variance, standard deviation squared. Moving on. Part A, calculate the probability that on any particular day the temperature will be above 20 degrees Celsius. Okay, well, we will just do the obvious thing, which is to write the probability that our temperature is above 20 degrees. Let me draw the diagram just to make it a little bit more clear. We have a bell curve. This is our temperature. We have the average right in the middle, 19.5. And we have 20 somewhere over here, and we want our temperature to exceed this value, so we're interested in this probability. We're interested in the area below this curve. So let's use what we know about the normal distribution. We go to our calculators, we go to our normal CDF, that's what we write, normal CDF, and we fill in the values in the order they ask. The lower bound, well, the smallest number here that we're interested in is 20. The upper bound is positive infinity, because remember, theoretically this extends towards infinity. Positive infinity on the right side, negative infinity on the left side. So we're going to represent that positive infinity as 9 times 10 to the power 99. Then we're going to put our mean value, which is 19.5, and the standard deviation, which is 0.75. We finish this off, check the calculator, and we would get 0.252. So that would be the first answer. Let's continue. Question B. We will have here, it is known that 30% of the days are less than T temperature, T Celsius degrees. Question B says, find the value of this T. Okay. Well, because we are interested in a value, not a probability, we have to use the inverse normal. So we'll do the following. I'm gonna draw this again, something like that. I'm gonna still have my temperature with the same values of 19.5. I want to have a certain temperature below a threshold that's gonna make this tail 30%. Remember, if this is 50%, right, because it's symmetrical around the mean, so half-half, I would argue that this is somewhat representative of 30%, but it doesn't have to be accurate because it's just a symbolic diagram. So this is my temperature I'm interested in. Now I'm going to write in my probability structure, probability bracket, and I'm gonna put there that T is less than a value T equals to 30%, which is 0.30 or 0.3. Okay, and then I'm going to use the inverse normal, which is inverse normal. I'm gonna put in my bracket the area, which is going to be 0.3, the mean 19.5, and the sigma of 0.75. All of this is on the calculator as always. Inverse normal is right underneath the normal CDF. So we put all these things on our calculator and check for the answer. That would be 19.1 degrees. So that's answer to question B. Let's solve question C. We have the following. We have Yejin finds the temperature in the office favorable for 80% of the days. Okay. Question C says, if the upper limit of the temperature for favorable days is 21 degrees Celsius, what's going to be the lower limit? Well, let's make use of another sketch one more time. It really helps. So here's our distribution of our temperature. Okay, we have the average of 19.5 over here, 19.5, and we want the following. We want the upper limit to be 21. So we know the following, that 21 degrees Celsius is here somewhere, roughly speaking. Okay, and this is the upper limit, so the upper threshold, meaning that my temperature is favorable at most at 21, and obviously it has to be less than 21 up to a certain threshold. That threshold is our lower limit that the question exactly asks for. So this is T lower. As you have heard, this is 80%. That region is 80%. So the question is, how do we go from this information all the way to the lower limit? Well, we're going to do the following. We are going to use some subtractions. So we're going to do, first of all, the probability. We can calculate the probability of our temperature to be less than 21 degrees. You might be wondering why. Well, because this is my thought process and the method I would recommend you to think about. I would take all of this thing, this probability, and then we can subtract it from the 80%, which is this piece over here. Alright, and then we're gonna find this small piece. And once we know this probability right to the left side of the lower limit, then we can use the inverse normal to find the lower limit. So we have to go through a couple of steps, but we'll take it one step at a time. So this probability of t being less than 21, that's going to be normal CDF, and I'm gonna put over there the lower bound, which is going to be negative infinity, the upper bound, which is going to be the 21, the mean, which is 19.5, and the standard deviation, which is 0.75. We do all that and just take the answer from the calculator, which would be 0.97724. 0.97724. Now, as I said, we can subtract 0.97724 minus 0.80 to calculate this small piece, this one over here. This is what I want right now. So this is going to be 0.17724. Now, as you can observe, this is very close to the answer, because now that we know that we have so let me make a note here, 0.17724. Now that we know this thingy, we can use the inverse normal. So we're gonna do the following. The probability of our temperature being below the lower limit, okay, this is T lower, lower limit for temperature, equals to this piece that we just calculated, which is 0.17724. So to calculate that lower limit, we're gonna do T lower equals to inverse normal, and we're gonna fill in the values in the calculator. The area is exactly this, the probability is the area of interest to us, which is 0.17724. The mean is going to be 19.5, and the standard deviation is going to be 0.75. We put all these values and look for the answer, and that answer would be 18.8 degrees Celsius, and that's going to be the lower limit in this case. Hope this all made sense, guys. I'll see you in the next one. We are done.